Hi guys, welcome to part 20 I believe of our little series on refactoring the Formatables model. So in the previous part what do? We got quite close to getting rid of the Formatables model, but then we ended up having to unwind our changes, and then we thought we would just be clever and implement the reducer as a transform, because this transform requires a different model from that transform. And this guy here requires the text model, whereas this guy here requires a logical model. And to make our life easier, we would move the reducer away over to the orchestration model, I believe. And that kind of was okay, but the problem was if we apply the removal transform before we apply the helpers expander, there's basically a dependency between these two transforms. If you apply the reducer before we apply the helper expander, then the helper expander doesn't expand because it's missing some types. So these transforms have a dependency. This must be applied first. Now that's easier said than done, because in order to do the helper expander transform, we now need to have PMM support for helpers, which is in itself a little mini effort. So we got a little bit stuck there. Now I was going to actually do this work without recording, because I think this is going to be pretty tricky. But we'll give it a go and see how it goes, and if we get too stuck, then we will start all over again and just stop recording. What we need to do first is we need to locate a sprint, perhaps about 2 sprints ago maybe. Not quite sure. I'm not even quite sure what the name of the story would have been, but we have a story somewhere here where we started adding some archetypes. Perhaps the one just before that. So we need a sprint where we did some archetypes. So the archetype is okay, this doesn't look too far off. So here we did a split. Maybe one more. Let's look for titles with the word archetype on it. Promote all formatters to archetypes. Okay, this sounding promising. Actually, what we're really looking for is logical support for physical model elements, really. Might be even one before. So perhaps if we look for physical on the title, towards the physical model. Right, this sounds like it. Bit of luck. Quite a lot of analysis here. I was hoping for just a really simple list of the things we need to change whenever we need to add a new physical element to the logical model. Okay, not quite sure what the easiest way is going to be to do this. Perhaps a grep. Problem is, what should we grep for? All the words are quite common, like stereotypes and so on. This is actually one problem with this way of capturing things. Everything is here, but the search is not particularly easy to do. So we've done most of the work, to be fair. We've added we've added the type to the logical model. There we are. So we've added the helper type. We've added enumeration. I mean, we probably need some stereotypes processing as well. Actually, I'll tell you what, I'm going to search for static stereotypes. I forgot to put a quote. Right, so no matches for that, fine. So what happens if we take away that? Aha, there we are. So we just didn't go far back enough. So sprint 21, how to add new Metamodel elements. That's exactly what we're looking for. So in some ways I was moaning about this, but in reality actually it just proves the opposite. As long as you can think of a query sensible-ish enough, you can always find anything around here. So create the namespace and the types and assets model. Add the enumerations to the meta type and static stereotypes, which we just did. As you can see here, we forgot to do the right thing here. Add the processing of a new stereotype to stereotype helpers. Okay. So that's what we're going to do next. So LSP workspace symbol. Right, so around here somewhere. This is all code that needs to be automatically generated or code generated. But so what we'll do is we will just follow the pattern. This is kind of exactly why we are designing Dogen, really. As you can see quite clearly here, it takes us 5 seconds to realize that there's going to be a pattern here, isn't it? And all you really want is for Dogen to take over here and generate this pattern, really. That's exactly why you need a code generator for. But we can't stop forever refactoring the code generator and redesigning and so on. We'll just have to get on with the current task at hand. So there you are. So we just added that. That will hopefully not cause any significant problems. Let's see what the next step is. So now we need to update the adapter. Which adapter was this? A bit warm in here. Adapter. Orchestration, presumably. Thought it would be orchestration. Downstairs. Let me see what's going on. It's all good. So what are we looking for then? There is an adapter. It was originally somewhere around orchestration. Slightly confused as to why we don't see any adapters here in orchestration, actually. Oh, I know why. It's because it's not called a projector. So a logical to physical projector, I should think. If I'm not wrong. No. There should have been an adapter in orchestration somewhere. Yes, this has been renamed to projectors. I wonder if we created a helper called adapter? Nope. Curious. This is not quite the code I expected. Oh, unless the projector is projecting. Yes, perhaps it is a projector, and I was right. It's just the wrong projector. So let's try the codec to logical. I suspect that's what we're looking for. Right, this looks a bit better. Okay, so if we just take this guy here and say yet another type here, converts the codec element to the stereotype or a helper, and we probably need now. Oh, something happened here. That should go somewhere around here. And if we just add the helper, and then this guy can return a helper. And there you are. It's just fairly straightforward. And in here we just take the part. Not sure how much commonality is going to be between the part and the helper, to be honest, but let's start with that. Okay, so we start by creating a helper. Then we'll have to populate the common things. Now, what we need to figure out is, we're not going to, maybe we need attributes actually. So, how are we going to populate the helper? As I said before, let's just make this the easiest possible thing. The helper needs 4 items, I believe, 4 or 5. 4, no 5 because in the ID as well. So, which reminds me, how did we supply the ID, I wonder? No, actually I think the ID will probably be just the helper's name itself, so that's fine. Family, owning formatters, owning facets, and the helper name. So I think, sadly, I think the only way to do here is to, let's think about this. We probably need some features for this. And interestingly enough, we already have some features in the logical model. Where does this projector live? Must be using some features already, presumably. Not quite, actually. So how exactly... Oh, I see. Okay, so presumably what we're trying to do at present is just the initial population. And then there's going to be a set of features somewhere else. Exactly, there we are. So as you can see here, there's this physical thing here. So you see, there's some work definitely required around here because it's all getting a little bit confusing. So we bundled all the features that are common to different types of physical elements in the logical model, and that's really not ideal because that now means that when we read, it attempts to read all of these, even though half of them don't make any sense. We probably needed like a physical underscore x, and then of course we then have these helpers here, but like I say, yet again, this is not supposed to be pretty. Let's just look at how these features are used in practice. So there we are. Okay, features are used around here. So we're going to take exactly the same approach and just put a few features, but I suspect there's going to be a physical elements transform. I assume on the pre-assembly chain. It will be around interesting area, physical entities transform. Okay, so we need to first convert, then update the transform. So I think there won't be much work to be done from here. I don't actually except similarly to archetypes, we probably want a property with the template itself. So in this particular case we have a property called stitch template content. Yes, we follow exactly the same approach here. So I think, well, let's just copy it from the source, because we also want to generate the template, so we get rid of all the existing madness that we got of the old templates. So let's just Let's just use exactly the same approach. So this guy here will have somewhere around here a text template or text templating, and for some reason we decided to call it Archetype text templating. This is going to be very, very, very dodgy, but I'm actually going to leave it as Archetype text templating, because reason being that we want most of this stuff except for relations, because we don't really care about relations, I don't think. But we won't have this in the future, right? We just need it for now. So the best bet is to just basically say this guy also has some Archetype text templating, as strange as that might sound, given we're not an archetype. We're kind of an archetype, I guess. Now we know this all temporary stuff, so we're not going to worry too much about that. And then we just make sure that we read the properties as we do for archetypes, exactly the same way, minus the relations perhaps. Which then covers us for a lot of this stuff. So I think that will be good. And in here we will just basically say you won't have pretty much anything except, well, we don't really want the part here, we want the archetype, I think. And I bet you the archetype will have, yeah, so you can see here we are doing the kind of work and it's doing. So I think this would do. Now it's going to moan about text templating because we haven't regenerated yet, but we'll leave it to it at the moment. And now I just have to figure out what this IA was. Oh, IA was just the name of the attribute, so that should have worked. Oh, we just called it attribute instead of IA. Which, to be fair, we probably shouldn't even call these things IE and IA because these were legacy names. So this is a codec element, and that's an attribute. I think that's fine. So we are gonna receive, see, as you can see here, everything's called IE. That's just historical. So these are codec elements. And to be fair, it might even be better to just call these things elements, because who cares, right? Don't particularly care. That way I don't have to worry every time a model changes name. And then in here, attribute seems to me a better name. So we'll stick to that. Right, so this is now making a bit more sense. And finally, we just need to co-generate. So, okay, what we're going to do is we're going to offload a couple of things. Let's just offload the work on the stereotypes helper, I think. So if I say something like logical add helper, so add physical helper to stereotypes helper. So that gets rid of that. Then what we then need to do is we need to generate a logical model. Right, and now I think it will just be a few minor changes to this guy. And with a bit of luck, that might even compile, because I think the changes that we did here are all sort of, well, I thought they were more or less self-contained, but compiler disagrees, so let's have a look. Okay, just the copying and pasting. Wow, we have a lot of bad copying and pasting here. So that's the name, that's the type. Don't need that guy. And we don't have an IA, so that's just matter. Right, so what we really want is just to get this thing to compile, all the tests to pass. Still other bits here that are not really that relevant. So we don't really have any of these things. Right, so we populate the common properties, we populate the stitch template related properties, which is literally just the content of the stitch template, and away we go. And I think that will take us there for the helper, for the projector. So now we've taken the elements from the codec space. Excuse me. Bit of a annoying cough. We've taken the element from the codec space. We moved it up to the logical space. But we haven't actually populated all the properties. So I think what we also need to do here is, well, if we look at our list again. So injection model to assets model transform. So that will be these days called something like codec to logical model. So presumably it's the other projector, I guess. No, not the other projector. And let's just go to transforms, I think. So something like codec model to logical model. This guy here. So this guy will probably be doing the dispatching. Well, here we are. And I think we just need, well, I think we just need something like this. And if I just change this guy to be a helper, and this guy to be a helper, this guy to be the helpers. Righty, so now then, this should, in theory, compile. Now what I'm going to do though is I'm going to basically say logical add text template to helper, physical helper just to, and then we could just say that the projector, we just added, so we had added physical helper to codec to logical projector. Projector. And finally we add physical helper to codec to logical model transform. So at this point in time we have a helper living inside of the model. We'll just commit this later on, I think. We have a projector living inside of the model, or the logical model. I'm sorry, we have a helper, should I say. It is not populated correctly though, it's going to be missing a lot of properties. So what we need now is we need to figure out this physical entities transform. For some reason we've gone caps lock. Okay. So this chap here, as you can imagine, this is going to be processing all the physical elements, and we just need, this is probably going to contain a few features here. So let's just have a quick look at how the features are being used here. So when we're processing the backends, we create the features, and presumably we copy across what we need. So the disadvantages of reusing these features is that if I just start adding even more stuff to here. The advantage is that we already have a few things that are right. So we have the whale template, reference, the logical meta element ID. Don't think we need that. Part ID, backend name. Well, we probably should have a part ID and a backend name, I should think. Which is a bit of a problem. Phone is not on silent. Let's just make sure we stop the noise. Right, so what we're saying then, yes, slight problems here. We need to make sure we can put the helpers in the right place when it comes to the physical model, because remember, we haven't even gone to the physical model just yet. At some point the physical model is going to contain a helper. That helper will belong probably to a facet, just like the archetypes. And that's going to cause problems because we need to figure out what facet to put the helper in. So in order to do that, we shall need a few properties. So I'm going to do something that's probably not the best thing to do, but is the straightforward thing to do, which is to add the properties to these guys here. However, one thing I don't quite understand is how come we don't have a facet, facet should I say, because surely we need, oh I know why, it's because of containment. So we probably know the facets. Let's have a look. How does an archetype know its facets? It's probably because, yeah, there you go. So facet yeah, as you can see here, these are containers, and because they are containers, they contain all the elements inside, and there will be a container here for facets, presumably. Here we are, and I suspect we just need to look through all the things the facet contains, figure out which ones are archetypes, and basically if it's a physical element of some kind, it just stops it. Alright, so it's fine. So we just determine that via the containment. So we can continue using the same logic, and that will then bind the helper. As you can see, the helpers are inside of facets. So that's going to bind the helper to the right facet. So I think that's fine. So what we will need is to put the, well, we'll add the properties here, that's easy enough. We'll look at the containment, so let's just start with that because that's the easiest thing to do really. Let's see how many of these we're going to need. I think I might just copy the helper over here so I can see properly. So we will need a family, we will need a set of owning formatters. There's no other way to know the owning formatters other than listing them. There's also no other way of knowing the owning facets. Ah, that's very interesting. So a helper does not necessarily belong to just one facet. It may be used by multiple facets, which is not declarable. So nothing in this world is easy really. So as you can see here, we have a very nice containment relationship where, for example, this guy here belongs to types. But there is an exception, and that is that certain helpers are being used across facets. Now this is really not very nice, but it's happening. So we have to cater for it. So this guy here belongs to I/O, but may sometimes be used in types. Which then means that we need somehow to create a relationship between the types that can own the facets that can own the type, the helper. So clearly the default, the containing facet is going to be the one that really matters, but not always. So what we'll do is, let's just jump over to the model. Actually, what was that a second ago? Okay, so it was something important. So if we just take any helper, particularly, well, first let's prove our point. Say we take a random one, say like hash, and then we just look at the helper, and let's just look at the containing owning facets. So as you can see here, I should think this is what we're going to see a lot. Almost all of them are going to return just one. So I think that's fine. However, if we go to I/O and take something like, I don't know, say pair, suddenly we have two here, types and I/O. So I think this is the exception. So if this is the exception, we'll assume that your owning formatter is always going to be the containing, and you can also add a list of formatters, of facets, should I say. And for the owning formatters, however, there's no other way. You're just going to have to explicitly list them. So then let's just go back to the logical model. What we'll do is, oh, sorry, I actually did not want to add a new one. I wanted to use the existing one. So sadly we have to keep these names. So no, actually we don't have to keep these names. So let's see what these things say. MASD.physical. So what we can do is we can do, for this particular case of the helpers, well, actually, if there's only one entry, which is the world template, I mean, I think we're being a bit lazy here. Let's not be so lazy. Let's just add a new one. It's better to keep the stuff that is going to be removed later all in separate classes, so we can just in the future just delete those classes, I think. So let's just say then that we have something like physical helper. I mean, these names are literally getting out of control, but so if we just say that there's a feature here for physical helpers, features related to helpers in physical domain, something like that. And then if we just say something like, well, I should think we need a lot of text. So the family, actually the first thing we want to do before we even do that is to say, let's put them in a nice separate place. So physical dot helpers, again something that we know for sure no one's using it. And then we can just go for family, and then the owning, actually we just probably copy and paste, I should think, to avoid typos. The owning facets, which is an overload, like I said, we will default to the containing one. The helper name, which I think, to be fair, is the actual name, isn't it? Oh no, we're doing some sort of hackery here. Excellent. So we need to choose one of the facets to make that the ID. I don't think this is overly important. I'm not sure if this is being used anywhere. Though to be fair, I think it is actually, because that's how we find the formatter so fine. Let's just call that whatever that is, helper name. And now the text templating stuff, I think all we need is the whale template reference. And the whale template is the incorrect name for mustache templates, so at some point we'll rename that correctly. Right, so that's a text, that's a text, that's a text. And these guys here are going to be text collections. Right, so here we are. So a whole bunch of features we got here. And related to the physical helpers, and let's just keep close all the physical stuff close together so that we can see the madness. Physical relations, physical, oh, actually just put it in the right order as well. Right, so there we are, a whole load of features related to the physical domain, and I think we may need some properties for these features. Yes, the thing that's most important is most of these things are optional, so family is not optional, I don't think. Owning format is not optional. Owning facets is optional. Helper name, well, because of all that madness, to be fair, what we're going to do with the helper name is this. We're going to create a convention. The first owning facet is always going to be the containing facet. So we're gonna generate this guy. The well-tempered reference is probably optional, because we may not need it. I think we always do. Actually, that's a good question. Do we even use well templates? So let's take a look at one of these guys here. Yeah, we do. So we do need a well template. So there we are. Right, so now then, with this we have pretty much all the features needed to read from configuration for the physical helpers. That's then going to populate our chap here, and that then will be used to generate the helpers, which we'll deal with in a second. I wonder if the helpers at this point in time are already called transforms. No, they're not, which is brilliant. Means we can just add the transforms and have them side by side, and then the only slight problem is how we're going to find these transforms. So at present we are relying on the formatters registering themselves. The helpers, well, actually, to be honest, I think it's fine. I think we just need to look at any of these initializers and we'll see that the helpers are also registering in the... exactly, okay. So that's fine. All of it seems to be looking quite good. It's pretty mental, but it probably will work. So then, let's generate these features. Let's see how we are in terms of kit. Okay, logical model has been modified. While we're here, we will just convert an event. And let's just generate. So whilst that's going on, must be clear. Strange error message. We seem to have oops, I know what we've done. Forgot to delete the copy and paste. Okay, so now we're doing for time. 40 minutes already, time flies. Right, so as you can see, we generated the helpers. Sorry, the features for the guy. It still looks quite good. Let's just make sure we didn't break anything. So all new features, so in theory should not really cause any problems. And it doesn't look like they are. So logical add features for physical helpers. Right, now then, if we just return to our entities, we need to deal with the helpers now. So at this point in time we have read the stitch template from the helper, and then we need to do whatever else we need to do here. I wonder if we instantiate... no, we don't instantiate it here, so there's going to be another bit of work that needs to be done in order to take that template and instantiate it. just so many transforms, it's a bit hard to see things. One thing we are doing more and more these days is to flip over. This is a C# hit, I should think. Another area for this. Starting to rely more and more on our org view of the models, because it's just so convenient. So if I look at the text.cpp model, you can see it here, and I can in theory just do a quick search here for, these are all different types, right? So if I just look for transforms, what was I looking for? I was looking for, oh yeah, the wrong model, logical model. Let's try again. Right, so if I look for transforms, there they are. Let me just close all these guys. In here, that's going to be a transform, which is something about templates. So let's just look for templates. Here we are. See, this is so much easier. I really want to move to this text-based view of the world, because it takes seconds to find things. Right, and now here, what we're going to see, hopefully, is that this guy here will bind, look for the archetypes, and as you can see, it finds the transform, and instantiates the whale transform. Interestingly enough, we don't seem to instantiate the stitch template, so presumably that's going to be something else. Right, so we have the render stitch template here, but we don't seem to have a transform to do this. Now I would have thought the logical model would be doing that, but might be wrong. Let's do a quick search. So if I just look for not quite what I meant to do. One thing I find with Elm is that if you're not careful, you have to really look at what Elm thinks it's doing. So for example, at the moment I just assumed it's going to say what it should say, but it's saying something else. I was using represent earlier, so right. So where are we using this thing? Somewhere must be rendering. Oh, of course, it's called an archetype rendering transform. Now, of course, all these names are all becoming quite confusing. I'm feeling more and more tempted to drop the word archetype from both of these transforms. Well, from the transform and the type. So we have an archetype rendering transform. There's the logic class templates, and there's the archetype rendering transform. So I should think the archetype rendering transform becomes sort of a rendering transform. As you can see here, we're just looping to the archetypes, but we need to loop through both. Interestingly enough, this seems very confusing because we seem to be re-rendering the whale template again. Right, so it seems like there's some confusion going on here. So we seem to have a logicless templates population transform, which was doing a bit of rendering, if I remember rightly. Ah, no, it's not actually. No, this is just my mistake. What this is doing is literally obtaining the content, I think. Yeah, so if you make a reference to a whale template, it will okay, so this is really not ideal. So let's stop here for a second and say we are getting a little bit lost here. So let's just say, before we can go further, so this is what we should really be doing. Improvements to template processing in logical model. So at present we resolve well template contents in a transform. And then instantiate, no, and then render both well and stitch templates in another, which is, as you can imagine, the rendering transform. This guy here, I should be start getting used to using ace jump. This Control C, okay. It's really difficult to use ace jump if you don't. It's one of those habits. It's hard to get into, but I need to because it's very useful. We need to merge these transforms and drop the archetype prefix. Okay, so that makes sense because we don't. I don't really like transformlets. I mean, a transform should be something that does lots of work, and on top of that, especially when there's a hard dependency, because this guy has to execute before that guy, so it really makes no sense to have these things separate. We have two little bits of code, so that's the first thing we need to do. Then once we're done with that, we should probably also drop the archetype, put the prefix on. So this is just so we can work through in our heads what we need to do here. And we just do a bit of mop up. Now I know for sure that a lot of this code is temporary, but still temporary could be 2 or 3 sprints, and it's very confusing if things are not conceptually, they don't make sense conceptually. So what we'll do is we'll take this little spike as the detour. Lost a minute somewhere, so let's just bump this by 1. Right, so we did take this little detour here. This is much better clocking than we were doing last sprint. So now what we're going to do is we're just going to mop up the templates, because we don't really want to add to the complications. It is interesting that we decided to put the relations on the templates. It's actually very, very strange we did that. Let's think about this. Why would you want to do that? The relations are actually property of the archetype, I would have thought. Not quite sure why we do that. So that renders the template. I wonder what the relations are being used for. Presumably, like, that is extremely strange. I think we're going to find is that the relations are being used in the factory. If I take any transform, say here, so I think that the relations are actually something that we do in the class implementation factory. Yeah, so you can see here we're going through relations here. Right, I suspect if I was to open up the template for this guy, archetype class implementation factory, let's just jump over to templates and let's find the archetype class implementation factory, and without a doubt I expect us to be looping to the relations here. There we are. and we seem to be looking at the relations in the archetype itself, right? Which it makes perfect sense. No mention of the word text templates, right? Why? Because the text templates are used to expand the text templates, right? So now it's very hard to understand why do we need to have relations here, and then if I go to the archetype, I have relations here too. Right, let's just, this is all sounding extremely strange, right? So let's go back to our story. And our story should say something like, drop relations in and see what breaks. Okay, so this is the strategy of the cleanup before we get into the real work. Let's have a look at how messy the world looks like. Doesn't look too messy at all. So what we'll do is I'm going to start by renaming archetype text templating. In this particular case, we're going to try something we don't try very often, which is we're going to do this in a two-step process. The first thing we're going to do is we're going to say, let's find archetype templating.hvp, and then let's just say, can we rename this type? I don't know, let's just call it text templating, say. Now that's going to go and change a whole lot of things. Okay, nice. Now we're going to look at the div, say whatever we need to say, please. And now let's see what is not code generated here. Well, interestingly enough, I think it's only code generated code. So I don't think this gave us much. Yeah, in this particular case, actually, this didn't really help a lot. So what we'll do is we'll just discard this nice little changes that LSP did for us. We're going to change the code generator. And I think we should only have to change two things. Archetype. Right, if all has gone according to plan, let's just do a generation of this first, just in case I break the world. Ah, interesting. Let's just show you what I see. Okay, C#. Interesting, interesting. We seem to be now that's peculiar. We are relying on this. I wouldn't have thought we need text templating here. Really strange. Okay, as you probably know, due to our current state of affairs, we can't see very much of what's going on, so we need to enable logging, go up to a log file, that model will do, and if we just have a look at the type that's complaining, the element properties. Now that is very strange. No, actually, do you know what? I think what's happening here is that we're not looking at the latest thing, whatever that is. So let's have a look at the logs again. CLI generate text dots. See, that looks about right, but why would this be element properties? Is that date correct? 1733, that's not quite right. Okay, what did we do with the logging? Did we not, we definitely enable logging. Why is this log file so old? Because we're looking at the wrong model. So text.c sharp. Text.c sharp is the one that wrote text and text.c sharp. So now there's clearly no references here to that. So let's just see what text has to say for himself. As you can see, there's absolutely nothing trivial around here. We've tried to do something that to me sounded like a 5-second job. And this is really not even the part that is really the hard part. So well, it seems really that the problem is the reference it's doing to the logical model. Simple type text templating qualified ID helper. Okay, this is just absolute stupidity. And now you can see what I mean by concentration. Clearly, we just did a change 5 seconds ago. We added text templating to another element, hilariously enough the one we're actually interested in, and we completely forgot about that. This is extremely expensive concentration, because every time we have one of these detours we flush the cache and we have to think about it again. It's quite annoying. Not quite sure if it's just a case that we're going to learn how to concentrate, or if it's just a fundamental property of my neocortex that you can't multitask. But we'll keep trying. I'd like to say that we've improved slightly. Right, so now then, with a very little bit of luck, we have done the first bit, which is just to drop the archetype bit there. Helper is using text templating properties. And next we'll drop the relations. Easy enough. Okay, so that's our first change. The second change we wanted to do is to see what happens if we get rid of relations. Now, well, first let's just do the thing that we need to do. And second, let's see what we get in terms of errors. Now I really hope that we're not going to get any errors, because for the life of me I've got no idea why we'd have exactly the same thing twice in two different places. And whilst that's doing its thing, we can now try to understand where to best place these things. So really, if what we're saying is true, what we really want is something like side by side of these two guys, something like this. In fact, I might even go as far as saying that I prefer this guy to go on that right. I don't know, maybe not. No. Problem is, it doesn't really fit. Oh well. Now I know we've done quite a lot of hacks around here, but I really can't see why we need relations in two different places, and particularly to do with text template properties. Right, there we are. We do. Now why do we do? See, we specifically saying here, read all relations for both the archetype and its generator. Right, okay, right, I know. Okay, fine, we can't do this. There is a reason for this. I can't remember what it is, but it is needed. So let's just leave it at that. These are two different kinds of relations, and this is actually really complicated code. So I don't want to touch it just now, because I think we're just going to break the world. All we'll do is to make sure that it's very clear that this hackery is taking place. We will just make sure the model makes it visible to everybody. Right, fine, whatever that is, let's just not worry about it just yet. I think this because we were trying to capture the notion of the relations in the template itself, and we will just leave that for another fight. So what we'll do is, let's just go back to this guy's here. Let's get rid of all of that. That's fine, we'll leave it as is. We don't really need that stash anymore. Okay, fine, so we can't do that. Actually, these are needed to model the template relations, which we have not yet completed. Right, fine, whatever that is, we just leave to that. So let's go into the meat of the story then. And the meat of the story is to merge these two transforms. So what we'll do is we will get these transforms side by side. First, before we start getting a bit ahead of ourselves, let's make sure that the only thing this thing does is resolve and copy. Okay, so that looks sensible to me. And then let's get the other archetype rendering transform. Let's just say that we're going to have a step here called populate. Let's call this first. Something like populate. Oh, I should have gone for a shortcut, shouldn't I? Populate the template. Replicate, copy the contents to archetypes that use them. Something like this. Maybe a static void. Template population. Now this guy here just needs a context and a model. You can see here. That seems simple enough to me. And if we put that at the top, of course, as you can imagine, we are rendering the that's because we probably have multiple parameters, different parameters in each of these renderings, so that's fine. So it doesn't really matter, we just copy the contents. And I think I'm going to be as bold as saying that all we need is this. Probably nothing else. Okay, fine, maybe a string. Okay. And then, well, interestingly enough, we don't seem to be using context for anything, so let's get rid of it. Probably just a tracing thing. Righty, so then, with this, we should be able to do something as simple as, well, we probably need two steps now, right? So we should probably say, render something like renders all templates, and we can say something like static void render all templates. I just don't like probably need the context for this particular one, I think. Well, I try with the context, see what happens. So if we then say something like, again, I think we don't need the context, but there you go. This is where AceJump is useful if you are good. Right, so this guy here now should give us some of the problem. So we put it here then. So then, okay, so you kind of get the gist of it. I don't think I thought that we had put the there we go. So then, I think with this we can do something like this: two top-level methods. I mean, the names are not particularly brilliant, but there we are. So start by copying across all the contents of all well templates to the the elements which is requirement, which is it. Okay, and then render all templates, stitch and well on all elements which have them. Okay, and now we have a slightly more sensible transform. And all we need to do is to go to the posts assembly chain, look for the logicless templates population, comment it out, run the tests, and with a bit of luck this will give us no diffs. Well, except for a few problems. We seem to be missing the logical ID, no problems. One thing that annoys me is that LSP does not pick up template related errors somehow. Right, so this is going to do its thing. Hopefully we're now down to only a few things, so we need these commits to all go in one go. So hopefully this will make no difference. There we are. So then logical merge template rendering and copying transforms. Now then, what we'll do is, before anything else, let's do the mop-up of the templates. This guy goes. Sometimes what tends to happen is that you start by doing one transform in isolation, and it makes perfect sense. And they do another transform in isolation, which also makes perfect sense. But we never really consider how they look together, which is probably what happened here. So now what we're going to do is mop up. And you can see how incremental we are. You could do all this in one commit, of course, but now this is going to break because the post assembly is probably including it. I'll just say something like this. Actually, it's not quite the error I expected. Seems like our... let's have a look at what we generated. most puzzling. I would not have expected. Seems like we still are generating this transform somehow. Not sure. Let's have a look at the chasing. Well, transform has been removed. Oh, forgot one thing, didn't we? Sorry. Sometimes you're not thinking straight. We forgot to actually regenerate the code. Here we are. Now the test will pass. Whilst that's going on, we will remove the transform. So, remove logic. That's templates, population, transform. Okay, test passed, all good. So now then, second thing to do is to call this a rendering transform. Maybe a template rendering transform, perhaps, to be very explicit about this job. And before we do that, one thing we always do when we do these renames is we must rename the files. So all we need to do here is to do something like crux buffer rename file and buffer. Similar here. And then we just need quick replace. Oh. Right, so presumably the post assembly chain would need quick. Okay, and I think if all goes well, this is all we need. And plus usual conversion and indentation. Right, so hopefully this will take us to where we want to be with a template rendering transform and text templates properties. No longer. So I prefer to clock my time when we're working properly and not getting too sidetracked. It's good to clock your time like this. When you work on a small story, self-contained story, just clock that story separately, really. You end up building up these massive stories with hours and hours of work, and then it makes it difficult to figure out what we actually did. So I think this is a very self-contained story. It's been shipped. So we move on. We just need to commit. Logical rename. Archetype rendering transform. Right, now then, so with the preparatory work out of the way, we have now put this laid this sort of the groundwork needed for the actual thing we're trying to do, which is we're still adding the helpers. I mean, as you can see here, this story is already 5 hours. That's fine. I think 5 hours is reasonable for one story. But let's think. So what are we trying to do now? We've put all the properties we wanted in this guy over here, including the text template and transforms. We're going to ignore the relations, as you think. We have added the features to this guy here. And now what we need is, if you detect a helper, we need you to populate the helper properties. Now before we do that, let's quickly have a look at the list of tasks. So create the namespaces, add enumerations, adapter, projector, typed reversal. Right, so we have to be just slightly careful before we do our work. Let's just make sure, because this will probably cause things to break. So this is where we are at the moment, meta type specific. But before we go on that, let's just quickly do the rest of these small tasks, because I think we may find strange breaks if we don't. So you can see why we're trying to avoid doing all of this, because we knew that the helpers were not particularly, well, they were not strategic, and we definitely did not want to have to do all this work to just remove it later on. And so we went through all this phase of not doing the work because we thought it would be just a waste of time, and the net result has been that we are moving a lot slower because there's so much mess, so much sort of temporary code lying around everywhere. That makes it almost impossible to think, because you're always thinking, oh well, yes, but that will be removed, oh yeah, but that will be changed. And then by the time you've done all of those ifs and buts, you can't actually concentrate on the thing you're supposed to be doing. Not quite that guy. Right, so do a quick test on this. So yeah, so this is painful without a doubt, and we'd rather not do this. But we tried not doing it, and to be honest, it's even more painful. So we shall just have to get on with it. Now that should be fine. So let's see what this guy does. There we are. So these are all very simple. What do we do here? Just have to follow the pattern. You see a lot of this code in Dogen, very sort of patternized codes, and you may think, oh wow, this is a bit, why do we have these codes so copy and paste code? The reason why is because we are already thinking about when we automate this code. It may not look very sensible right now, but hopefully at some point in the future we're all just going to generate a transform for or a code generation template for one of these guys. So that's, we already are trying to design code that the code generator can generate. That's why you see this sort of heavily patterned code. Right, let's try again to run our tests and look at our lists. So yeah, so it was looking quite good. So we just need to worry about the merge transform next and commit all these things individually, and I think we'll be there. Again, the merge transform is probably not going to look pretty, but let's just look for parts. That will be the helpers and the helpers. I think that's the only place where we need to worry about. Okay, so as you can see here, that gave us so let me just commit these guys. Add helpers to element reversal. We can do the factory and the transform at the same time. Add helpers to meta naming transform and factory. And finally, let's just make sure that the test covered the last change as well. Add helpers to merge transform. That seems to be going okay. Okay, so yes, the reason why I wanted to do this is just to make sure we're not going to have some strange errors once we start populating. So we're done with that. Once you start populating properties. Good, all green. Okay, now then, the same way we've got all this process, we need another process here. Processes all the representations of helpers. Right, very simple. We will not worry about the relations just yet. Interestingly enough, some of these guys are returning, well, not this particular one. So we will just return void. Right, so what should we do then? We will need something very similar to what we're doing for the archetypes, I should think. So now the archetypes are organized by IDs. Now the parts are organized by IDs. So the presumption here is that the archetype has to have a part. I don't think we can get away without a part here too. So let's think about this. Where is the part coming into the archetype? Part ID. We did not add a part. So what would happen if we don't add a part? I think the problem will be that if we don't add a part, when we start moving towards creating paths via the data-driven approach, we won't be able to create paths for helpers because they need to belong to a part, and I think we can't get away with that. And then the other question is, what are we doing at the moment? Have we assigned parts to every single archetype? Probably via... yeah, we have assigned it via these clever configuration things. So, okay, nothing for it. We have to go back and add a part ID. So the part ID is probably just a std string. Clearly we should probably just make a concept or a template for this, but so the archetype is a part. We have a part. The archetype has a facet name and a backend name. Again, I don't think we can get away without these. And now you can start to see what's going to happen in a second, which is we're going to have half of the properties here, the other half here. Perhaps we just need to read both, which means we probably don't need the well-temperate reference there. Well, it's not to get too hung up on this, right? So backend name, and then a facet name. Oh, to be honest, what is this facet name? Yeah, correct. Interesting that we call that the part ID rather than the part name. Everything else is name, but I'm not too sure. But anyway, it should really be the complete. Let's have a look. What is there populated? So say facet name. They exist, but they're not. Oh, okay, this is just so that we can generate an ID. So presumably we must do a lookup, I guess. Lookup for the part. So I guess what we're going to find is that on the facets we populate the archetype names. Yeah, here you go. So all the bits of the archetype get populated nicely, and we need to do something similar to... Right, so the problem we're going to have now in a second is that facets only have archetypes, not helpers, so no problem. So let's just create a container. Interestingly enough, I wonder how we find these archetypes then. We do a lookup. And arcs are probably going to be physical elements. Okay, correct. So, okay, cool. This looks fine. So we need similarly to do helpers. We just put these next to the archetypes just for a laugh. Right, so now the facets will contain the helpers. We do a quick lookup for the helpers. We populate these little tiny properties there and there. And then we read everything else in config. And then we have the helpers, I should think. Problem, of course, is that we won't be able to compile for now, so let's just get rid of this for a second. If I just generate the code. So we're working on the logical model. Do a quick conversion. Right, so what we'd expect to see now is facets and helpers have been updated. And a bit of luck, tests will pass. Then we just need to make sure that the helpers are processed very much like everything else. So I suspect this is not going to give us particularly huge amounts of problems, so let's advance with the commits. Add missing properties to facet and helpers. Helper. Okay, that passed. Okay, now then, where are we? We are going to, well, let's start with the facet. So the facet is going to attempt to root. So if we find interesting that we didn't just bomb out after we've done so if we located the qualified name, it seems a bit silly to continue to look for it everywhere else, so I think we just continue here. Similarly, we can just say helpers. Not sure if this helps, but there you are. And if you could just create a different thingamajig for it. So if you can't find the helper, or if you can find the helper, we can just be very careful here. We want the helpers. We want the helper container. Then we just populate. Just populate what needs populating. Interestingly enough, major technical space. I don't think we have a major technical space. I'm not sure why we don't, but we don't seem to have a major technical space. I think maybe for now. Interesting, right? I wonder if we added it and forgot about it. Perhaps it's because, yeah, we are physical elements, so we have it already, so that's not a problem. Okay, cool. And then finally, we can say we contain the helper. And then again we can just continue. Now what we'll do is, just to avoid problems, let's just make sure that these changes here don't break the world. We don't need to commit this guy here, but we can in theory. So we're now in 30 minutes. Oh, it would help if you know what to spell. Continue. Thank you very much, spell checker. I think I'm getting dyslexic in my old age. Right, so now, if everything is going according to plan, nothing will break, and we should be populating the properties of the helper. Good, no breakage. So we'll just commit that because it seems simple enough. So let's just say logical populate facet properties for helpers. So properties from facets in helpers. Populates. No, I don't like this. Populates facet properties in helpers. No. Populate helpers facet properties in physical entities transform. That's a bit better. Okay, and then now that we've done that, we can go to the next step, which is well, sadly discontinued thing is the last thing the undo has got. So let's go for what's the clipboard. Okay, so now then. Okay, that wasn't quite my intention. It's better. Now then. Now we've populated the containment aspects. One thing I wonder that may have not been done correctly is let's just look at the containment transform actually, because I wonder if we have to handle these things manually. It is possible that we're not adding the containments. No, we're doing an elements resistor, so I think it's but look. Right, so this probably would be a problem. Okay, so let's imagine I am a facet. What does a facet do? Sort and validate. Well, what does the updated do first? Any element. Okay, it seems pretty generic. Okay, this looks pretty generic, so hopefully this means that we are actually now processing these new types. Okay, so we'll assume that until we have evidence we're not. Now, we organize the parts. I'm not sure why we need all this part stuff, but let's have a look at why. I just need to add ourselves to the part. Now, given that we don't do that just yet, I think we can get away with not doing it. I wonder what would happen if I did a using here. Seems better. So I think we are just going to ignore that bit here. Straight into the archetypes. And then we're going to take some of this. Don't think we need all of this, but okay. Probably all the way up to here. Right, so that looks vaguely sensible. We'll just drop it here. See, this is another thing we do here that we don't really tend to do at work. At work, normally, you would, instead of all this copying and pasting, you would go through a lot of code reviews, and we would create lots and lots of code that will be very generic. And so there'll be no copying and pasting. And it's good to have that when we have a big team with lots of code reviewing. But one thing we found when working by ourselves in well, a team of one, is that actually copying and pasting is easier, because what we do with copying and pasting is we copy and paste, and then we start to see patterns, and then when we see the pattern, then we abstract it, and it's really easy to refactor a pattern because we've already got something to validate against. So once we've got all these bits and pieces here, at some point we're going to go to this transform, we're going to spot lots of commonalities and say, oh yeah, that should be in a function. And then it's really a 5-second job. Well, what's not a 5-second job is to figure out those commonalities before you see the patterns. That takes a lot of thinking. Now this wouldn't work in a company, of course, because you would never have time to go back and refactor. But here we try to go and refactor. Well, I'm just going to call this helper. H would probably be enough, but... Right, so we don't seem to have a Metamodel name either. I think we need a Metamodel name, sadly, because I reckon the Metamodel name is used to construct an archetype name, and everything needs it, so I'm not sure why. As you can see, Metamodel name is pretty much everywhere. So let's just do a quick hack here. Basically a property of the interface of a physical element. So and now what we can do is we can just get rid of all of these instances. Okay, so what this will give us is we will move that property there. Everyone will and this is exactly what you see now. This was just in action, what I just said a second ago, copying, pasting versus refactoring. So what we tend to do is we just do it, and then once you spot the pattern, as I can already see a couple, for example, everything has to have a backend. So when you spot the pattern, just go for it, remove it. And this makes it really easy. I don't have to think too much about why that field was added or why it's here. All I care is that when I do this refactoring, everything that was working before is still working now. And that's pretty cool, because I don't really have to worry about... okay, the backend name is here as well. I don't really have to worry about really thinking quite deeply about all the possible permutations that could possibly happen. All I need to do is to say, well, it was working before, should work now, and the code should not change, the generated code. So it's much easier to refactor after you got a set of patterns than it is before these have been copy and pasted. That was the lesson I think we learned here in Dogen. Copy and pasting, think of copy and pasting as collecting a set of observations, and then think of the final refactoring as an experiment, an hypothesis that you're making. And the hypothesis will be that after making this change, nothing will break. And once you've collected the observations, we now can make a theory, right? And you can validate that theory against the observed data. So it's a much easier way of doing things. Okay, I think we've finished refactoring here. Don't see any more obvious commonalities. I mean, you can see things like directory name and facet name that exist in a couple, but not everywhere. So we're not going to go too crazy. Right, so what we're going to do now is we're just going to code generate that guy. As usual, we need to convert, indent. 、 bit of luck, we might need to comment out some stuff. So we'll do this. We'll just get rid of that for a second and try to run all tests. Now we expect some things to move, but nothing should break really. You can see here things are going to move. Let's make sure we don't commit the transform. It says something like adds properties to physical element, add common properties to physical element object template. Noise downstairs, see what's going on. Usual family chaos. So if we, okay, the tests have passed, we can check that in. And now then, hopefully a little bit of this stuff will become a bit more. Oh, did we forget to add the Metamodel in? No, we didn't. Okay, that's another problem. So, where is my parts? Let's put our helper here. And then, right, good. So this is, oh, well, I thought this was an improvement, but so then what we're going to do is we're going to make the static configuration off of our helper, and then we're going to read the properties. I don't think we have a logical meta element ID, if I'm honest, because your helper doesn't really latch on to specific. Yes, because you can have the same helper presumably against multiple logical elements. So let's just remove that for now. We don't have relations either. We will have a well template, so we might have gone a little bit too crazy over there. Yeah, there we are. So we will need this guy here. So let's just get rid of that. We don't really have relations in our well template, so to be fair, actually no, let's just not do that, because we probably will. We don't have them now, but we will have them in the future, because if the relations exist, it's because they express some logic inside of the well template, and I don't really remember what that logic is, but well, we have a template, so why don't we see relations? Yes, because we never did add the relations, and I actually think this is going to be a problem. So yet again we need to make another little spike here. We need the relations on the helper itself. Reason being that the relations model static relationships between model relationships between element types, and I think what's going to happen is the helper will contribute towards that. I mean, really, don't really want to go too crazy on this. I'm hoping that we don't have to touch any of this code by the time we get to relations, because hopefully we would have moved over to the PMM. We would have moved over to PDMs, and the PDMs won't require helpers, so we can get rid of all of this infrastructure. It's really painful, but I'm trying very hard not to think that this code needs to be removed at some point. It's a bit difficult when you know what you need to do, but that's actually sideways to the target. Right, so helpers now have relations. Let's just to make sure, let's just double check we're not going to break the world. Going to comment this out. I should think we're very close to getting this to compile, so if we just remove then technical space, and then finally we assemble the ID, which is not going to quite be like this. Okay, I don't think we have a technical space per se. So let's just get rid of that for a second. We will have an ID. So if we just populate this guy here properly. Right, this is not exactly brilliant just yet, but hopefully. Struggling a bit at the moment typing. Right, so we don't really add the helpers to the parts, so I don't think this is much of an issue. Right, so a bit of luck. And now we just need to make sure that in these cases where we are referencing archetypes, we start talking about helpers. I think even the typing suffers a bit from concentration, lapses of concentration. Okay, so that looks pretty green. Let's see what happens if we attempt to run all tests on this. Now we don't really want to commit the transform itself just yet. Now bear in mind that we don't have any archetypes just yet for helpers, so nothing is going to happen. But we should do a test very soon. So okay, let's be realistic about this video. We are already in almost 2 hours. I think we're going to have to conclude very soon. We've managed to progress a fair bit. Okay, it's all green, so let's just say logical add. What did we add? We added relations to physical helpers, and then we have our first stab at implementing the physical entities transform. Now, what we'll do with this is that we're gonna hook in the processing of the helpers. I don't think that's gonna break the world, so well, we have an hypothesis that it's not gonna break the world. Let's try that hypothesis, and if it works. So at this point in time, all that we'll be achieving is, if you have a model and you instantiate a helper in that model, hopefully the helper will be progressed all the way from initial codec, projection to logical model. Logical model, there'll be some processing, not all processing, because we're still missing the feature bits, second bits of the feature, and then that's it. It stops there because there's nothing else for it. So what we'll do is we'll just call this perhaps something like first stab at adding helper to physical entities transform. Doesn't do anything particularly special, but it doesn't break anything either, so that's good. We will compile the code generator, and for good measure we shall start to add our first helpers. So now you just have to bear in mind that there's 2 steps to this. There's the adding the helper itself, and there's the adding of the formatter for the helper. So what we're going to do for now, we're going to add the helper. So can't call it smart pointer helper, because else we don't have problems with that guy. Let's just call it smart pointer helper new, or new helper, perhaps. And let's give it an archetype of MASD physical helper. remember we need a property here of type stitch template content, so we will put one in, and we probably need a color for it, ideally not too far from an archetype, so 68D. So if we try what do we see around 68D? Some kind of greenery. Perhaps lighter, I guess? No, not too light because the facet itself, maybe darker then. What if it's a bit too dark? Dark but still readable, hopefully. Okay, that seems distinctive enough. Now, of course, it probably will moan at quite a number of things at the moment. For example, we need to latch onto a stitch template for the helper, and so presumably we need some kind of configuration for this. Let's look at these guys here. Do they have a stitch template? No, actually this is going to be a whale template, I should think. Yeah, there we are. So actually we can start removing some of these keys that we're not using anymore. For example, we're not using the locator anymore, so but importantly we have the whale template configuration here. So if I create perhaps a helper, so the key thing to think about this is what would the helper need. So as you can see here, there's a whole lot of transforms, templates. These are the mustache templates we for whatever reason call logicless or whale. All these names are not really very good names, but so we have an artifact transformator. Somewhere around here we should see. No, we don't see any helper transforms here. Ah, here we are. Sorry, going blind. So there's the header. There's the implementation, and implementation enabled, whatever that means. So each of these will bind to a different transform. So a different template, should I say? So perhaps what we need is something like well, actually, do you know what? Before we start getting really clever, let's just do something really simple. Let's just say, well, we'll just bind one. So, Dogen MASD.physical whale templates reference, and I want the whale template reference to be, and now this is where it becomes interesting really, because there's a lot of template references, so I'm not quite sure which one to choose from all of these. I mean, there's only one archetype, the helper, so it's not obvious. Well, to be honest, we have no idea what we're doing right now, so let's just say we choose a random one. So, I don't know, let's take enabled, whatever that means. This code hasn't been touched in a very long time, so it's going to be a rediscovery. Right, so that gives us the starting point. Now, what else is it mandatory for these guys to have? Probably a part. So what we'll do is we'll just copy a few of these things here. Again, not obvious what parts these guys should go into because... Oh, I see. No, we're making a mistake at the moment. We have to bear in mind that we're instantiating the helper, not... Yes, this is a classical meta-modeling error. This is not the helper archetype, this is just a helper. So we don't need any of this stuff. What we need is really just a helper. We will instantiate the helper archetype in a second, but for now, it has to look just like, say, a class. So now, what does a class need? That's more important, really. Yeah, the problem I think is going to be that you can't just instantiate a helper. Well, this metaprogramming is really where where the rubber meets the road. This is where it becomes interesting. So we're trying to create an instance of an archetype, and this archetype will be used for code generation. It will generate new helpers. The helpers would have four different archetypes which we haven't created just yet. The helper type here just represents that idea. Then it will then be projected across those archetypes that we're going to add in a minute that we haven't just yet. So I think this is probably all we need. I mean, this is very confusing, but I think this is all we need. I think if all goes according to plan, and if I just run all tests on this, if you attempt to code generate with this, it should kick in all the code that we just added that we were not testing a second ago. Okay, so it did something. Not quite what you expect, but alrighty. So we're cooking with gas somehow. Let's add some logging. I don't really like seg faults, but clearly we assume something somewhere where we shouldn't. Sorry, actually I didn't mean to do that. I meant to make sure we got latest code generator and generate. Well, let's just generate all models, I guess. Only one is going to break, but here we are. So look for text.cpp. Right, there we are. So the physical entities transform blew up. Right, so what are we doing then? We're processing the logical ID. Okay. So we're processing the feature types, the ID of the feature types, and then contains archetypes. So just after we finish containing the archetypes, we seem to have gone a bit bonkers. So presumably facet processing. This actually looks quite sensible. Can't see why this would break. So as you can see, we saw all those contain archetypes. Let's just change this ever so slightly so that we output just prior to doing anything. Didn't really mean to run all tests. I meant to recompile the code generator and then generate again. Right, I'm not sure we're going to go much further in this video, particularly with these problems. We didn't expect to have nasty problems just yet. I'll say that the memory management that we've been using Dogen is very lax. That's why we have seg faults every so often. A lot of assumptions here and there. Sometimes we'd wish we'd had Rust. Not much change here. So the seg fault is happening before the logging, interestingly enough. Just read this very well. To be honest, there's always a very simple thing we can do. Comment this bit out, but I want to read this a little bit carefully. So, or it could actually just be that we are seg faulting No, I think we still have to process all the archetypes. So yeah, we are segfaulting here. So we're basically saying if you can find the helper, this could imply that the helper is null, because we are dereferencing the helper. The reason why we didn't expect the helper to be null, of course, is because the adapter will be, well, projecting it with a type, with a value. So let's just say something like fix me qn dot value, or even just qn, I should think. No, that value, fine, whatever. Let's again get a new code generator. Okay, I think we hit the 2-hour mark. Yep, so we're gonna have to start closing this video down. The one last attempt just to see what the log file says, and then we go. So, not ideal really, a bit stuck with this slight issue. Right, so we seem to, interesting. Notice how we processed 2. Now that is slightly unexpected. Presumably, oh actually no, it's not entirely unexpected. Of course there's a type in there, and then all we're doing here is we're validating that that type is an archetype. So we never finish processing facets. So let's see what happens then when we have a type here which is not of so we got here, we printed the output. If it's different from the end, well, clearly this is the problem, right? Oh. Typical copy and paste error. Now you see why copy and pasting is a bad thing to do. Very bad thing to do. But it also has its advantages. Right, now then, I'm actually not even gonna bother. Oh, not even gonna bother with let's go back to logging, because I think we screwed up our logging area. See, this is what I dislike about winner. It's like where we actually need winner. Winner does not. Here we are. Good. Sometimes it works. Right, so let's just run our tests. Yeah, you can see that why languages like Rust tend to be a better choice for this kind of work, because this would have been a compile error in Rust, and it would be nice to have a borrow check in C++ for sure. Okay, now we're moaning because we don't have a meta element name. So I think meta element name. I wonder where meta element name is going to be supplied. Sadly, this is the kind of work that really requires a lot of concentration. So you see here we are supplying a meta element name. Now I don't... Oh, actually meta element. Let's have a look. Why do you think we need the meta element name? So the meta elements we have a meta element ID. Right, so the problem with this is that a helper can't have a meta element ID, because a helper can bind to multiple archetypes, and that means that to be fair, they're probably always going to be one archetype, which is always going to be the object, but it could be primitive, for example. So you could have that same helper being used for primitive, and which means that it's not possible to bind to a meta element ID. Now, I think we've made a modeling error by saying that we didn't actually. So we probably just made a mistake. Where is the Metamodel name? But there's no meta element name. So archetype presumably must have a meta element name. Not obvious. So how is this meta element name used then? The logical. Okay, fine. I think perhaps this is just a case of saying copy and paste it too much. And we could maybe just, we're removing it in the arc. Helpless. Not sure where this was commented on before, but that's been commented. Metamodel name. Oh, I think the problem is actually with the feature itself. The feature itself is probably saying meta element ID is optional true. Okay. Not entirely sure what's going on here, to be honest. Meta element name not supplied. So I don't see meta element name not being supplied here in the helpers. Let's look for line 595. Yeah, so I think this perhaps does not make any sense. So we're just gonna get this thing to compile. Once it compiles and runs all tests, and we haven't achieved very much, to be fair, but once we've managed to get this thing to compile, it means we've instantiated the Metamodel element. Now it's not going to be a particularly brilliant Metamodel element, but hopefully we'll do something. Right, now we have another seg fault. What other mistake have we done? I wonder if tt.configuration. I should think we're gonna have problems here. Let's just stop that for a second. So let's put a fix me here, perhaps. Ensure template config is populated. Right, so now then, hopefully, we're not really expecting very much at the moment. We just need, okay, name must not be an empty ID. So now we have a problem on 265. While processing facets, interestingly enough. No, okay, it's just the post assembly validator. Okay, right. I think let's have a look at the post assembly validator. We're probably just missing logical meta name. I would have thought that the meta name would have been populated. So clear wire. Okay, right, this is going to require a little bit of thinking. Right, so we'll stop here. Already gone past 2 hours anyway. So what's happened then? We've managed to add a lot of infrastructure related to reading the new logical metamodel element, which represents a physical concept, and we are somehow able to instantiate this concept, this new element, and it should really come to life and do a few things, not very much, but a few things, but it's not. And the reason why is because when it enters the pipeline, once you start to process the guy, it starts to break. There's a few problems in the way that that's being instantiated. The problem is we really need to sit down and focus and update all the properties correctly, and then at some point this guy is going to start coming out. Once that happens and the guy is actually coming out and there's something on it, it doesn't have to be brilliant, we can then go and create, the archetypes that we need to process that physical model element. We add them here just like we added everything else, and then that will give us something coming out as a template. So what we'll do is we'll do all that meta work offline, and then we'll resume once that's done, because it's actually quite tricky work and I'm finding it we're going very slowly at the moment. Okay, thanks for watching this part.